Hello, my name is Justin Goodman, and I'm here to share about why water quality matters. One day in science, my science teacher, Ms. Shulman, taught me and my class how to monitor the water quality in our hydroponic systems. We had farmed in the systems and eaten the crops, but I always wondered how they worked. I was amazed. I wanted to investigate how these numbers affected how the crops grew. I offered to help out with them immediately. So every Wednesday, I go to the science room to measure and record the EC and pH of the plants and make suggestions on how to correct any imbalances. You might be wondering what EC and pH measure or why these measurements are important to know in a hydroponic farm. What is EC? EC means electrical conductivity and gives us information about the nutrient level of the water. The nutrients react to the water, such as nitrogen, magnesium, and potassium, are in salt form. These electrolytes allow electricity to travel faster, so the higher, the more the EC, the more nutrients in the water. Even though you need these nutrients, too much can be as bad as not enough. What is pH? pH is the amount of acidity in water. The lower the number, the more acidic. pH is measured on a scale of 1 to 15. The closer to 15, the more non-acidic or basic it is. Drinking water's average pH is 7.2. The water for the plants in the science room are much more acidic. Each crop has a preferred pH. When the pH is off, it can interfere with the crop's ability to absorb nutrients. You might be wondering how pH and EC help hydroponic farmer scientists like yourselves make decisions on how to manage water quality in your systems. Let's look at my data chart for an example. This is the data for the EC and pH for the plants at the science room. On days where they were out of range, the plants were a little off. If this was the case, we would try to fix it with less or more nutrients, or pH plus or pH minus. Though sometimes we would give a plant more nutrients on purpose so it could grow faster. Look at the mulch 30th row. For the VCS or vine crops, the EC was in range, but the pH was a little low. The water needs to be a little bit more acidic, or the crops may not be able to absorb the nutrients correctly. The rest of the systems were in range. This was one of the better weeks. Learning about water quality in my school made me think about how important water quality is. If you drink water with bad water quality, it can be dangerous. Additionally, if plants don't receive the right amount of nutrients, they could die and a food shortage could happen. In New York, we're very lucky to have good water quality, though in many places it is not the same. The agriculture industry uses almost 70% of the freshwater sources on Earth. Increasingly nutrient-depleted soil requires the use of fertilizer, which is one of the top sources of contamination in rivers and streams, and causes toxic algae bloom, harming wildlife in the area. Other pollutants like oil and radioactive substances also are problems. Managing water quality in your systems to grow crops in ideal conditions is much easier than managing the water quality in our lakes, springs, and oceans. Acidification of our water resources is a huge issue that is already destroying life in our oceans. Pollution is shrinking our available water resources for food systems and human drinking water. So what can you do? Make sure you don't dump household chemicals such as laundry detergents, oil, and cleaning products down the drain. Don't waste water. It might be one of the most important resources we have. Reduce your carbon footprint as greenhouse gases interact with the environment, creating acid rain and more acidic oceans. What you choose to do can make the difference. Let's all work together to make our world a better place.